Today we'll start with a new chapter, chapter 8. The title of the chapter is Network Security. Uh, let's first look into the chapter goals. So we will try to understand the principles of network security, what is cryptography and its many uses uh, beyond the confidentiality. We will try to understand what do we mean by authentication, what is message integrity, as well as we try to also explore what is the security in practice, firewall or intrusion detection system in web services, security in application transport and network, as well as link layer. So let's start with the first definition. What is network security? So a network security is actually composed of different actually ideas. So we will actually explore those ideas. So aggregation or composition of all these ideas, all these actually factors actually makes up the network security. The first and foremost important part is confidentiality. So uh, there is two party while a communication is going on, one sender and one intended receiver. So the message that actually sender is sending, the receiver should get the message and no one else should know that message. So that actually confirms the confidentiality. So how do we achieve that? So we know that there are some encryption methods. We will actually explore those as well. So sender will encrypt the message. The plain text message will be converted to a gibberish encrypted message, and that message cannot be. We are hoping that some other party cannot read this encrypted message, and only the receiver should able to decrypt the message and actually see the contents of the message. So that actually suffices the confidentiality component. So the next one is authentication. So before going to actually going into the communication, you first need to confirm that whether the identity is true or not. So a receiver should check whether he is talking to the intended sender, and sender should check did he send a message, or is he going to send a message to the intended receiver. So what do I mean by that? So actually there could be some situation where some receiver actually some adversary web services or enemy nodes can actually mimic the face of or mimic the condition of a receiver. So you see that whenever if you are going to your email address www.gmail.com, so for that email address, for that web address, there is an IP address that is coming from a DNS server. Okay, so there could be some situation where your DNS server's data packet that is received by you from the DNS, it is actually breached, and you have given with a spoofed address, that means a wrong address, IP address. So and that IP address is hosting a similar kind of Gmail web service where they just take your username and password, and they are just getting away with it. So very important information, they can just get it back. So what happened is actually whenever you send a message, so before that the your web browser should have some way to authenticate that whether he's contacting the right person or not, as well as whenever at the middle of the program whether some sender is replaced by some other person or not, some other device or not, it should be checked by the receiver as well. So this is also falls under the actually scrutiny of network security. Next one is message integrity. So the message that I am sending, whether the actual message is received by the sender or not. So that is another question. So there could be some sensitive information present in my message, as in that I am actually, my web browser is contacting my actually bank account, bank web service, and from my web client, I'm sending a message that debit this amount and send it to this send it to my father. Okay, so that's my father's account. So that's what message I have sent out. But there could be situation that as it is going through a public network, if an adversary or enemy just look into the message and just change it, instead of my father's account, it just changes to his own account. So and the if the receiver, that means my bank web client, if cannot find out that whether the message was actually the message from the actual client or not, if it cannot find out, then there is a grave danger, isn't it? So the message integrity is also falls under the network security purpose. So you have to whenever we are actually giving our network security, we need to think about these situations as well. Next one is operation security. So assume that instead of changing information, posing as different, posing as your friend, all those things, instead of that, there could be other situation like DDoS attack, denial of service attack. So in that case, actually what you are doing is actually sending a request which is not the right request. Like whenever actually SSC or HSC result is coming up online, everyone is trying to actually access the result. That's why the web server was very busy to give you the reply. Or Dhaka University's result or any university's result, the web server actually it replies with very actually significant amount of delay. Okay, so if the pressure is the original one, then there is no problem. But there could be some adversary person, like okay, like me as a very bad person. What I can do is actually sending a request which is not necessary. I'm just sending that give me the result of this address, this role, this role, but that role is not present. I just make up a code and just wanted to flood that web server with with lots of actually requests. So the web server should have some mechanism to identify me, that this is an enemy or this is an adversary. This is not a right request. This is not a valid request. So I should stop it. I should not accept that request. So these cases can be filtered out by the operational security. That organization can build up a firewall program which actually nothing but filter out the request. So whenever it sees that similar request is coming from a single data source by actually a lot of time, so it can actually blacklist my IP address and actually stop taking the request from the stop taking request. So firewall actually stops my request from getting into the web server. Okay, as well as intrusion detection system, as it can actually try to find out whether some data is actually taken away by the middleman or not. So that is the whether there is an intrusion in my system or not. It can be find out by specialized software. So those software can be actually used to give the operational security. So throughout this course, throughout this chapter, we will use this three-person, Alice, Bob, and Trudy, where Alice and Bob is the right person. That means one will be the sender, another will be the receiver. And Trudy is the enemy, or Trudy is the attacker, or Trudy is the adversary person. So, so in network security world, these three character is used several times. So they say Alice and Bob, and Trudy is the bad person with a horn. Okay, so that's very illustrious. Okay, so what happens is Trudy as an intruder will actually intercept, delete, or add message. So we just understand that part. So Alice has some data. It use the secure sender option, and using the channel it is sending to the Bob, and Bob as a secure receiver will receive that and find out, extract the data. So that is the idea. But in case of Trudy, what will happen? He or she will intercept the data and try to actually try to actually change the data or add the data or delete some data to actually complete his own bad goal. Okay. So in real life, who are these Bobs and Trudy's? Sorry, Bobs and Alice's, and who are Trudy? Like I just gave an example of actually browsing in the email address. So you see that this web browser could be Alice, and the server could be Bob. Okay, so I am from the browser. You are actually sending out something like it could be an e-commerce website where I am placing order, but at the time of checkout, some prick do what actually changes my order and add something for his own and add it and send it out. So I got a bill of the actually product that I was not intending to order, but that particular actually prick or Trudy is actually intrude on my message and give the different command. Okay, so there could be online client and server. I just gave an example of online banking system. The DNS server, that is also actually I just gave an idea, because DNS server holds all the mapping for which IP for which domain name service, what will be the actually IP address. So those things are actually given in that DNS server. If I can actually change something in the DNS server, or the communication the DNS server is compromised, then I will actually be taken to a malicious website. I can be taken to a malicious website. Then routers exchanging routing table updates. So this is also a good example where whenever routing table was updated, we can deliberately delete some routing path from the routing table update and include our own, so that some data can be actually so all data will be coming through my path. So that could be another intention, that if there are multiple paths, all there could be a situation that the packets will be rerouted to another path. So what I want is to actually take all the packets from my path. So I just actually change the information of the router. So there could be a networking security issue on different layer. Okay, so that's what is mentioned here, and we'll try to understand some of them. Okay. So what a bad guy can do is eavesdrop, listen to message which is confidential, impersonation. That means the authentication was not actually fully done or incorrectly done. Then actively insert or data, so integrity of the message will be compromised. Then hijacking, just taking over the connection. It's like impersonation, but in this case assuming that they were in the communication, and you are actually hijacking the communication. Then denial of services, we have mentioned that also, that you are requesting invalid request or unreasonable or unnecessary request to a web service, so that web services resources is blocked for the real and necessary actually call. Okay, so that is the denial of services. Now we'll talk about principle of cryptography. So our main goal is to look into the message integrity part. So how can we give an integrity to a message, and which degree? So cryptography is a process of encrypting a plain text into a cipher text. Cipher text means encrypted message, and there are two terms necessary: cryptanalysis and cipher. So cipher means the algorithm that is used to encrypt the data, and cryptanalysis actually finding out the process of deciphering the encrypted message. Assume that you don't know that what is the cipher is used. Yeah, from looking at the encrypted message and the decrypted message, you are trying to guess what is the actually deciphering algorithm. So that is the crypto analysis. So what is the general structure of a cryptography? So assume that Alice wants to send this plain text message to receiver Bob, but if Trudy can actually change something. So Trudy can actually add something or read something, so the confidentiality or integrity is compromised. So what is Alice will do, use an encryption method, which encryption method requires an encryption key called Ka, and that encryption key will be used in the encryption algorithm, and the plain text will be taken as an input and a cipher text will be created. So this cipher text will go through the channel where the Trudy can access the cipher text, but if the Trudy don't have the access to the encryption algorithm or encryption key, it cannot identify what will be the cipher text, and then sends to the decryption algorithm. That means actually Alice and Bob already knows what will be the algorithm to encrypt and decrypt, and what will be the encryption key and decryption key. So that is decided on a different session. Okay, and we are actually assuming that Trudy did not hijack that information. So using the decryption algorithm and the decryption key of Bob, the value will be the plain text will be generated. So this can be written in this message in this way, that m is the plain text message, m for message, and you are actually encrypting it with a key called Ka. So this is encryption is written in this manner, Ka in bracket m, and that is the ciphertext C. The ciphertext C will be created, and this is called the encryption with Ka. Now, if you want to decrypt it, what you do, you will use KB on this encrypted information or ciphertext. So as you can see, this in this case, the decryption algorithm takes the ciphertext and the KB to get the plain text. So this is the ciphertext KAM, that is this one, denoted by C. So if you use the decryption algorithm, that means if you use the KB as a decryption algorithm, you will get back the plain message M. So that is the general idea, and for different type of encryption algorithm, we will use specific things. Okay. So there are two types of cryptography. One is the symmetric cryptography, and another is asymmetric key cryptography. So let me rephrase it. Let me say it again. Symmetric key cryptography. So from the name, you understand that the key that will be used in this cryptographic method is symmetric. So why do I need symmetric key, and what does that mean? As you see that for encryption you need one encryption key, and decryption you need another decryption key. So in this case, symmetric key means from the key is actually same. That means the key for encryption and key for decryption is same or similar. That means from one another can be generated very easily. Okay. So and they are called shared secret key, and for both encryption and decryption message. In case of symmetric cryptography, you can assume a box is a safety deposit box is present, and there is only one door, and there is only one lock, and one key is actually you have one key, and your actually your receiver has another key. So that is the shared key. So they are the same key that is used to open up this door to read the message and write the message, or keep the message and take out the message. But this problem is actually if Trudy can guess the actually Trudy can identify the symmetric key, then he or she can also get the message. The problem is actually whenever you are trying to agree on a symmetric key, that is the problem when Trudy will actually will get the value. That means whenever actually you are trying to share the symmetric key, there could be some, if the process or technique is not right, Trudy can actually hijack your symmetric key. In case of asymmetric key, that is also known as public key. So in this case, two different key pair is used, and from one pair, from one key another key cannot be created easily. Okay, it is not an easy process computationally. It is very hard process to find out the private key. Okay, so one key is for writing the message into the that safety deposit box. Another key is to read the message. So what happened is, in this internet scenario, internet days, many person needs to communicate with a single web server, like Facebook. I want to communicate, you want to communicate, others want to communicate. So what happened is, Facebook actually shared its public key to all. So whenever I just send a request, my web browser actually encrypted it with a public key, and no one can actually decrypt it without the private key. That means the private key cannot, without private key, this cannot be decrypted. So this is a specialized type of cryptography, and mathematically it is possible. So symmetric keys actually make more sense, that one key is to read and one key is to write. That makes more sense. So same key is to open up the situation, but in case of asymmetric key, it is possible to actually make an encryption algorithm where asymmetric key is required, where publicly everyone will be available with a public key. Everyone will write that data into the safety deposit box with one door, that is public door, where you can write it and put it there. And if you want to see what is present in this box, you have the private door, and only with a private key it can be find out. Okay, so this is very this private key is actually competition is very difficult to find out. So that's why actually with certainty you can communicate with Facebook, your bank account, over the internet. So let's start with the symmetric key cryptography. So the first example is Caesar cipher, which is attributed by by King Julius Caesar. I think he is a king. I forgot the history. You can check out the history. The history is not the focus of our syllabus, but to know how the encryption process is working. So this is very straightforward process, and I think if you are actually, if you do scouting in scouting program in your school life or college life, you have came across this type of cipher technique. Okay, so Caesar cipher, here actually what happened is, change the each of the text, each of the letter of the text to another text. Okay, so and what will be the another text? It is defined by the shifting key value. So what happened is, if you just write out the all the letter A, B, C, D, E, F, G, I just write these three this letter and just dot dot dot. And if the shifting key value is 3, that means this needs to be chosen. This is the key, you can say, for Caesar cipher. So Caesar cipher is the actually algorithm, and key is the value 3. So you just write what shifted by three elements. So A will be actually A will be replaced by D, B will be replaced by E, then F, and so on. So in this way actually G, H, I, J, in this way actually it will be go on. So it is easier to find out what will be the substitution later. Okay, so what happened is, from the plain text, actually for each of the from this table it can find out that what will be the shifted 3 letter. Okay, so that is the cipher text, and this is very actually easy to write it on pen and paper as well. So there could be some question where you will given with the key value plain text, and you will be asked to form the cipher text using Caesar cipher. Okay, or it could be in reverse order, from the cipher text to plain text. You may need to find out. So can be easily broken by using only 25 possible key values. So as you are seeing that you just actually changes shifted by 3. So all there is actually possibility of 25 possible keys. So you can even actually make an analysis. That is the cryptanalysis. You can just go through it and find out what will be the key value, and you can just decrypt it. Okay, by guessing, you can say. So in this case, this symmetric key cryptography, what is the process? So Caesar cipher is also a symmetric key, as in we said that in this case shared key will be used, one key for encryption and the same key for decryption. Here the key is actually k is equals to 3. The algorithm, encryption algorithm, is the Caesar cipher. So using this key value, Caesar cipher will convert this plain text M message into a cipher text KSM. Okay. So now this is coming to the Bob's part. So he has the decryption algorithm, use the same shared key, and find out the plain text from the cipher text. So that is the question, that how do Bob and Alice agree on a key value? So that is the actually major question for symmetric key cryptography. Next one we will talk about is another class of encryption scheme called Monoalphabetic Cipher. This is an improvement of Caesar cipher. You see that only 25 possible cases of the key and you can find out the result. But what happens is, if we can actually substitute each letter by different random shifting key. So if it is random shifting key for each of the letter, and if they are unique, then you can have more possibilities. Actually, the possibility becomes 10 to the power 26 letter, because for each letter there could be 26 actually variation or option to check out. Okay, so any letter can be substituted by any other letter as long as each letter has unique substitution letter, and it can use the random shifting key. So here is an example. The plain text is plain text, that means all the letters are written, and you see that for A the value is M, B for N, but for C another random value B. Okay, so just ensure that for each of the letter there is a unique key. That's it. In this way, the plain text from any plain text, the ciphertext can be calculated. So encryption key mapping from set of 26 letter to 26 letters. So that is the case. So there are 26 factorial. So actually not 10 to the power 26, like 26 factorial is the case, and this is close to 10 to the power 26. Okay, so possible. You see that you have actually permutation cases here. So you can have some statistical analysis to break this key event. So what is the statistical analysis? Actually, for there is a problem for in each of the language. Statistically saying, in normal conversation or in normal text, you will find the letter E and letter T in high frequency. So you can check out that what is in the cipher text, which letter is coming again and again, and assume that that could be an value E. Okay, so or T, and try to find out the plain text from that key. Okay, so that is the idea, that how you can actually find out the using the statistical analysis to find out the plain text. Okay, or break the encryption algorithm. So let's go other. Let's look into the breaking of an encryption scheme. What are other cases? So ciphertext only attack. That means Trudy has the ciphertext that I just mentioned earlier. You can have. You can just check out different way, all the ways. So that is the brute force. Search through all possible keys. In case of Caesar cipher, the possible cases are 25, but in case of actually monoalphabetic substitution process, substitution encryption algorithm, you have actually 10 to the power 26, in order of 10 to the power 26 keys. So if you go through the brute force, 10 to the power 26, even not that actually high for a computer program. It is difficult for a human to find out, but it is not that much difficult for a machine. Then you have the statistical analysis. Instead of searching through all possible keys, you are finding out some candidate key. That means what will be the statistical, what are the keys that is coming again and again, assuming that variable, that value, that key, and trying to find out the result. So that is another process of breaking the encryption algorithm. Now, other than that, you have known plain text attack. In this case, you have only the cipher text. Now you assume that you know the plain text as well. So Trudy has plain text corresponding to a cipher text. If it is found, then it is very easy to find out the break the monoalphabetic cipher. For somehow, if actually this is going out, then it can actually get the result. Okay, so assume that for some reason Facebook is actually sending out congratulations, you are logged in. This message is as encrypted, and Trudy knows it. Assume that. So for all these messages sent out, so Trudy can actually try to understand what will be the what will be the what will be the cipher text for that. So an intruder can actually guess, because if it has some pattern that always it sends out these things, so they can actually try to guess what will be the actually result. Okay, what will be the plain text if they are using monoalphabetic cipher. So that will be very easy to break. Chosen plain text attack, assume that you have a web server which encrypted, but it sometimes actually returns reply like this, that I don't understand your request, then your request information. So all of them are encrypted, assume that. Okay, so what you can do is actually sending out a plain text intentionally to get all possible substitution link up. So what you will do, actually send a message like a brown fox jumps over a fence. So those actually idioms, you know that all 26 letter is present there. So if you just send that, and the web server is actually encrypting that particular message and return it back, then you can easily actually check out what will be the plain text. Okay, so in this way, the the attack can be take place. So that will be all for today. We will start from this topic, polyalphabetic encryption, in the next day. Okay. If